Assalamualaikum warahmatullahi wabarakatuh. We are from group 9. We want to do some video presentation for subject Geotechnic 2 for title A Study on Slope Stabilization of Embankment by Using Coal Waste. For the members from group 9, firstly is Muhammad Aminuddin bin Khalid. Second, Muhammad Azizi Solih bin Azhar. Third, Muhammad Nasiruddin bin Baharudin. Fourth, Muhammad Izzat Najmi bin Muhammad Azam. Fifth, Nazarul Amin bin Nazri. And sixth, Abdul Rahman Abdullahi Ali. For introduction, slope stability is the process of calculating and assessing how much stress a particular slope can manage before failing. Examples of common slopes including roads for commercial use, dams, excavated slopes, and soft road rail trails in reservoirs, forests, and parks. Considering the importance of slope stability to their work, it is beneficial for civil engineering to understand how to properly evaluate slope stability and leverage various techniques to achieve slope stabilization. The most common failure in slope come from the relatively shallow topsoil, which further worsened by the depth of weathering and infiltration during rainstorm situation. Slopes can collapse easily by shear if the soil is nearly saturated, and high pressure can be built up rapidly. The falling debris carried by its potential and momentum can rush down the slope at very high speed and travel a long distance, causing huge damages. Besides, highly decomposed rock in slope behave very similar to soil. Slope failure depend on soil type, soil stratification, groundwater, seepage, and slope geometry. A common type of failure is homogeneous fine-grained soil or rotational slide that has its point of rotation on an imaginary axis parallel to the slope. Embankment is consistent with a series of compacted layers of leaf of suitable material placed on top of each other until the level of subgrade surface is reached. The components of embankment construction are least thickness material and degree of compaction. Coal mining waste is divided by the source of extraction, type of fuel, plasticity number of mineral metals, content of fuel, grading and chemical and mineralogical composition, softening interval, and the degree of swelling. Coal mining waste also has a high content of coal in the rock, more stable grading and substance composition, lower sandstone and sulfur content, and higher mudstone content. One of the specific features of coal waste is heterogeneity of its grading. Therefore, to use coal waste in the construction of strong, sustainable, stable integrated embankment are available to classify it when do the construction. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day I wish for everyone. My name is Muhammad Aminuddin bin Khalid, DF190164. Today I will present about literature review about find and cost coal waste and importance of aggregate of coal waste. First, find and cost coal waste. For fine coal waste, it was produced in the second stage of preparation of coal for a high-quality metallurgical coal, that is separating process of metal from ore. Then it is pumped in as a watery mixture of insoluble metal into tailing ponds where sorting of the particles occur. So the difference with coarse coal waste, for fine coal waste, it consists of smaller particles which are predominantly rich in carbon material. The particles are angular and it nearly have the same size or the spread in multiple directions. Next is the coarse coal waste. Fresh coarse coal waste produced from the separation of plant. It has its own particle size range which is from gravel to sand. The largest size of particles may be found up to 5 inches in diameter, its petrographic composition is affecting the long term of properties in engineering. This petrographic composition can be divided into three types of composition, which are low quality coal and carbonaceous shale, shale and mudstone, and sandstone and siltstones. But from these three type of composition, the most stable rock type is the sandstone. It is because sandstone is the least influence on engineering properties. The mudstone and shale have poor influence on engineering properties as the weathering of these petrographic properties resulting in oxidation of pyrite. The effect of the oxidation of pyrite in the moist embankment is it can influence the properties, whereas it can be produced and risk on damaging any structure of embankment. The second thing for the literature review is the importance of aggregate of coal waste. Coal waste is heterogeneity of its grading. Reducing to coarse particles of mining dump rock occurs as a result of weathering involving weakening the material over time and at short-term processing, which is at compaction when the break of weak grains age occurs. Weathering of the coarse coal waste is an important consideration in the design of coal waste embankment because it may change the coal waste properties with time and thereby affect their long-term stability. It's also one important aspect in which the coarse coal waste embankment differ from common earth and rock embankment. Weathering may be mechanical, which is physical, and chemical, with the coarse coal waste being susceptible to both. Okay, that's all from me. We will continue our presentation with my friend Azharul Amin. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today I'm going to explain about aggregate strength rate. As we know, in this study we use coal waste as our aggregate for the slope embankment. In this study we propose to classify coal waste by aggregate strength rate. To determine the aggregate strength rate, we need to determine the percentage of indestructible particles under the influence of climatic and technological factors. What is the climatic and technological factors? Climatic factors are the cycle of wetting, drying and freezing thawing, while technological factors including soil compaction during construction of the embankment. Furthermore, the determination of characteristic of the rock in its original state involves two states, which is initial states and final state. For the initial state, it provides 3 cycles of climate, impact, and compaction effects, while the final state, it provides 10 cycles of climate impact and compaction effects. What is the cycle? One cycle of wetting drying involves total immersion of large particle in the water for 2 hours and drying the particles to reach the constant weight by the samples within 22 hours. As we can look in this slide, the graph shows the result of the analysis of the aggregate strength rate. For the line number 1 until 3, we use burnt rock. For the line 4 until 5, we use fresh rock. And last line, which is line number 6, we use unburnt rock. For the result, we can conclude that the burnt rock has the highest strength rate at the range of 70% and above, and the lowest rate is fresh rock. So that's all for the literature review of aggregate strength rate. Now I will continue with the methodology. We use laboratory tests as our method. Actually, the laboratory test is much similar to the literature review that I have explained just now. So we take a look the procedure of the laboratory test. First, we determine the grading of original coal waste from the mines and dressing works. Second, conducted a research of climatic and technological impacts on stability of large particles in coal waste. The climatic and technological impacts, like I've just explained just now, which is climatic is related to the freezing and thawing and wetting drying, while technological impacts is the impact of the soil compaction during the construction. Third, we record the result from the research. Next, the aggregate strength rate of coal waste was determined from the result obtained. We can we can determine the result by refer to the graph. And lastly, the strength of the entire system and the changes in its structure under compaction effects and drying compaction effects was evaluated. So that's all for the procedure of the laboratory test. For the next methodology, my group members will continue.
Assalamu alaikum wa rahmatullah. My name is Abdurrahman Abdullahi Ali. My matric number is AF180286. In here I am going to present about development of impact. Nowadays, the rational structure of coil waste embankment are developed constantly. The development is carried out based on all the specific criteria such as properties of the embankment, height, and the embankment width. The cross-section embankment calculation will be carried out when using fresh coil waste. Furthermore, the relevance of the high embankment for placement of insulting layers. Protective screen installation needed to be determined by calculation. After that, 0.4 meter thickness of bent rock and a protective insulting layer of loam are arranged each 2.5 meter of the layer of fresh rock. In order to avoid the possibility of exothermic heat of the rock of the embankment like shown in the figure. The embankment structure also is designed using aggregate weak rock based on the creation of density to achieve by compaction. Using of inorganic binder material are important to gain stabilization and ensure the reliability of the embankment body performance. Based on the embankment design, vegetation soil like grass is provided to cover the embankment as shown in figure number 2. Meanwhile, the embankment structure using aggregate strong coil waste is not different from the type structure for the coarse soil. It is only different for the elements that are introduced, if necessary, in accordance with the fireproof calculation. Certain amount of hydrolabile rock contained in coil waste should not be taken lightly as it potentially destroyed causing oxidants and uneven deformation. In order to overcome this problem, the most effective option is fine grain by fill in the maximum number of pores between coarse particles. By the influence of the weather and the climatic factors, the aggregate strength in the embankment structure will provide the isolation of embankment body. To prevent the weathering of the rock and the penetration of moisture into the pigment body, the protective screen on the lobes are being added. The protective screen are protected inorganic binder. The usage of cement or lime also need to be noted to ensure the durability, reliability, and the stability of the embankment. That's it for me. Thank you.
Bismillahirrahmanirrahim and Assalamualaikum. And salam sejahtera to Dr. Phyllis. My name is Muhammad Azizi Fahim bin Azhar with my number of DF190113. Today I'm going to present to you about the result and discussion of our projects. Okay, the advantages for using coal as the improvement on embankments is coal waste can be found in any quarry that undergo the production of coal. Both fine and coarse coal waste can be available in large amount in this country, which means the countries are developing. Okay, the usage of this coal waste is limiting the potential of global warming, where it would capture and store the carbon dioxide release into the atmosphere. The current global reserve are about 1 trillion too many of tons of coal. This means coal is not threatened source, such other fossil fuels like petroleum, which the quantity is very low and needed daily. Okay, the disadvantage, but if we using coal as our improvement on embankments is coal is not renewable source where they manage to be depleted if the coal continuously commit as daily energy of all engineering properties. Coal mines use an open cast method which causes local animal habitats to be destroyed, and coal usually burned underground, so they need forests to undergo the mines, and if we cut down the forest, the animals will lose their habitats. Okay, people who are exposed to coal and its emission have an increase of experiencing asthma and others severe condition on breathing system. And breathing in coal dust or ash is also known to be cause for lung cancer development over time. So if we stay on in the coal mines for a long time, it can develop cancer on our lungs. Okay, the last one is coal mining disease called black lung, as we can see in this picture. Freeze-dried human lung, black lung, and the sample was taken from the dead coal workers. Okay, coal mining disease called black lung can impact the total lung capacity. Is incurable, no vaccine or something else, and is often fatal, which means death. Okay, you can see from here, freeze-dried human lung. Normal one is very, very clean, and the black lung is very, very dark because exposed to coal mining, and of course, he is the coal workers. Okay, that's all from me. Thank you very much.
Hi, my name is Muhammad Izzat Najmi bin Muhammad Azam. My metric number is DF190057. For my part, I will present to you the conclusions for our project. Okay, for the question is, the study shows that coal waste contains a mixture of strong waterproof particles and hydrolyte that can soak, and a fine-grained component mainly formed during weathering. Density and strength of coal waste are totally depends on lithification of coal-containing rock. From the laboratory test, it shows that the highest strength is the rock that was exposed to burning, which is burnt rock, and the lowest strength is specific unburned rock and weathered rock. The analysis of research results shows the down-mining rock can be heterogeneous by its structures and properties. Then, grading also varies greatly within the slag heap. From this research study, the coal waste contain particles of varying and resistant to weathering, which is it cannot be used for construction of subgrade without prior stabilizations. Next, stabilization or strengthening by cement will increase adhesions between coal waste particles due to setting and bonding. To apply coal waste in the construction of strong, stable embankment, it is needed to classify them. The strength of the aggregate system following compaction is regarded as a guideline for evaluating the possibility of creating dense structure. And lastly, the use of causeway for construction of strong, sustainable and stable embankments involves the necessity to develop special structural and technological solutions according to classifications. And that's all from me. Thank you.